Good morning to all. Today I am going to discuss about simple LR parsing. So in the previous session we have seen what is LR parsing. Okay. So what is SLR parser? SLR is a simple LR. It is the smallest class of grammar having few number of states. Simple LR is very easy to construct and it is similar to LR parsing. The only difference we have is it is difference between SLR and LR is that in LR parser table there is a chance of shift reduce conflict because we are entering reduce corresponding to all the terminal state. We can solve this problem by entering reduce corresponding to follow of LHS of production in the terminating state. So this is called SLR of one collection of items. So various steps involved in the SLR parsing is writing the augmented grammar. So check before that, check the grammar is ambiguity or not. Okay. So first writing the augmented grammar, and the second one is LR of zero item collection of items to be found, and draw a data flow diagram, then construct a SLR of one parsing table. Okay. So these are the steps involved while constructing our SLR parse table. So the steps which we use to construct SLR of one table, it is given below. See here, if a state I of I is going to some other state, that is I of j, on a terminal, then it corresponds to a shift to move in the action part. See the example. A here, A implies dot AA. Consider this production. It is parsing on A. So it will become A implies A dot A, right? So for this production, we are writing the SLR, constructing the SLR table as action A. So this is dollar here, accepting state. So go to directly A because we have A productions here. So states, we have the two states in this I and I of j. So we don't have any reduced states here. If a state I is going to some other state, that is ij, on a variable, then it is corresponded to go to move in the go to part. Okay, so it is move, go, we have go to move in this go to part. If a state I contains the final item like A implies A B dash. So we have seen this in LN of zero items, right? So which has no transitions to the next state, then the production is known as reduced production. Okay, for all the terminals X in follow of A, write the reduced entry along with their production numbers. For example, consider this grammar S implies dot A implies alpha beta dot. So follow of S is we have to find first follow of the given non-terminal. So follow of S is dollar here. So follow of A is small here. Follow of A is here. We have small. Here nothing is there. So we have directly we can take shift here. So for that we are constructed A implies alpha beta, constructing action and go to part here. So it is moving to the, it is moving an action AB, then dollar, that is moving to S and A. So consider this grammar. For example, S implies E implies E plus T or T implies T star F or F implies ID. So construct what we have to do. First to construct, first step is we have to write the augmented production for the given grammar. How to write the augmented production? By adding the dot symbol, inserting dot symbol at the first position of every production in the given grammar. So that is S dash implies dot E implies dot E plus T, E implies dot T. So all the productions we are adding the symbol dot. Okay, so consider the I naught state, add augmented production to the I naught state, then it compute to the closure. So that will become S implies S dash implies dot E. So after dot, all the after dot we have the E here. So add all the production which is starting with E into the I naught state, because dot is followed by here. We have a non-terminal. So we have I naught becomes S dash implies dot E, then E becomes, because we are writing the dot E productions. Again, we have after dot T here. So add all the T productions to the I naught state. See, final the I naught items will become S dash implies dot E. So dot E productions we are writing, and dot T productions also we are writing. Again, we have dot F. So dot F, F productions we have dot ID. So we don't have any productions for ID. So no need to take any new production in this. So what our I1 will become, go to I naught on E. So what we have to pass now, after dot, what are all the terminals and non-terminals, that all the states we have to take. We have here E, T, F and ID, right? So for first one, we have to take start with the start symbol. Go to I naught comma E. It will become closure to the S dash implies E dot. E implies E dash plus T. So E dot, what are all the dot T productions we can take here? E dot dash E dot plus T. So E dot plus T here. So I naught on T. So dot T productions, what are the dot T productions here? T dot and T dot star F here. T dot T dot T dot star F here. So again on F, where it is moving? On F, we have only one production. So it will become F dot, right? So that will become F dot. So I naught and ID, only one we have. This will become ID dot. This will become ID dot. So again, I1 on plus. Okay, I1 we have, what are all the production? After dot we have plus production. Again, so I1 on plus, it will become E implies E plus. This dot is going to pass to the next terminal. So plus E plus dot T. Add all the productions what we have with the T. Okay, because we have after dot we have T here, we have to write all the T productions to the I5 state. So I5 state will become E implies E plus dot T, and dot T productions are these two. T implies dot T and star F, T implies dot F. So again we need to add F productions here. F implies dot ID. ID we don't have any new productions. So no need to write for terminals. Again go to I5 of F will become T implies F dot. It is same as I3. Okay. So go to I5 comma ID. Here I5 comma ID. ID it will become ID dot. It is same as I4 here. F implies ID dot. So now add all the production which is starting with the F, because we have after dot we have here F here. So in I6 state it will become I6, what we have got first, T implies T star dot F. Then after dot we have F productions here, F implies dot ID. Okay, next go to ID, I6 on ID. So that closure will become F of ID. ID dot will become, dot ID will become ID dot. So this is same as I4. See here, in I4 what we have, F implies ID dot. So no need to take any new item number here. We have already same as we have in I4. So you can take same I4 here. So I7, what is I7 now? I5 comma T, I5 comma T. So T dot star F, it will become T dot star F. So it will become E implies E plus T star. So E implies E plus T dot. Next, I8 will become I6 on F. It is moving T implies T star F dot. So it is moving the end of the production here. So now we'll see DFA here. What we have done, augmented grammar we have constructed. Next to canonical collection of item, same like LR parsing. And again, we have to construct DFA here. So consider the augmented grammar. Okay, after dot, what are all the terminals and non-terminals we have to pass from that state? Okay, so first one, after dot we have E here. So again, S dash implies E dot. E dot, again here we have dot E here. So E implies E dot plus T. For plus we don't have any production, so no need to write the productions in this I1. Okay, again after dot we have T here. So for on T we have to pass to the new state. So that will become E implies T dot, and this will become T dot star F. Okay, again we have after dot we have F here. So from here I naught on F, it is moving to the T implies, this will passed already, that will become T implies F dot. So I naught on ID, it will become F implies ID dot. Okay, same thing which we have done for I naught. So here also after dot, what are all the terminals and non-terminals, any special symbol that we have to pass. If there is any same items or repeated, you can take the same thing. You can directly map to the same item. So this is our SLR table. We have shifts and reduce here. I naught and ID, it is moving. I naught and ID, it is moving to the I4. So that will become S4. Okay. So I naught on 1. So in action, what are all the terminals we have? ID plus star and the dollar symbol which is accepted state. We have to take always star, dollar symbol here. When we have a terminals, you have to mention in the action table. Okay. If you have non-terminals, then always we should mention in the go to section. From I0 to ID, it is moving on shift to 4. I0 on E, it is moving. I0 on E, it is moving first state. I0 on T, it is moving to the second item. I0 and F, it is moving to the I3, that is third state, third item. Okay. In this way, we are going to construct SLR table. So thank you for listening. We are going to discuss CLR table in the next session.